Our final story tonight is a bit of a reach all the way to Neptune. The little spacecraft that could, Voyager 2, is heading for its closest encounter yet with the planet Neptune. It's now billions of miles from Earth. Voyager has been making new discoveries and sending back pictures from space during a fantastic journey that began way back in 1977.
Hey there, space enthusiasts. Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. 35 years ago marked a historic milestone as humanity ventured for the first time to Neptune, the farthest known major planet in our solar system. Using a spacecraft with computing power comparable to a calculator, NASA's Voyager 2 mission returned breathtaking photos that unveiled the majestic ice giant in its entirety, bathed in shades of blue. These images represent the closest and most revealing glimpses we have captured of this elusive planet. Initiating its journey in August 1977, Voyager 2 embarked on an unprecedented expedition across the solar system, eventually becoming the first and only spacecraft to explore all 4 outer planets. It reached Neptune in 1989, 12 years after its epic odyssey began. As Voyager 2 approached Neptune, it unveiled a world cloaked in blue-hued clouds, resembling a sibling of Jupiter. The spacecraft captured a monumental slate-colored storm raging through Neptune's atmosphere, along with the discovery of 4 previously unknown rings and 6 new moons. Voyager 2's fleeting rendezvous with Neptune, spanning 7.1 billion kilometers, provided humanity with unparalleled views of the planet. Among the enduring images is Voyager 2's iconic portrait of Neptune, showcasing its towering white clouds, massive storms, and the famous, albeit inaccurately depicted, deep blue color. In reality, Neptune appears in a lighter, more greenish-blue hue than commonly portrayed. If you search the internet for additional photos of this impressive ice giant, you'll find only a handful available, which may come as a surprise given that Voyager 2 approached as close as 4,950 kilometers to Neptune. However, capturing clear images of the ice giant is challenging. Neptune orbits on average 30 times farther from the Sun than Earth, receiving minimal sunlight. When Voyager 2 reached Neptune after gravitational assists from other outer planets, it was traveling at a high speed of 27 kilometers/second, resulting in a brief encounter. Due to Voyager 2's high velocity and Neptune's low sunlight exposure, which is only 0.1% of Earth's, obtaining sharp, detailed photos of the planet was incredibly difficult. Despite these challenges, Voyager 2 managed to capture some of the closest images ever taken of Neptune by using long exposure techniques and maneuvering the spacecraft to rotate as it passed by. One particularly detailed close-up image, taken just 2 hours before Voyager 2's closest approach, reveals long white cirrus clouds suspended high in Neptune's atmosphere. Unlike Earth's clouds, these are composed of frozen methane. These cloud streaks span thousands of kilometers parallel to Neptune's equator, with individual streaks measuring between 50 to 200 kilometers wide. Notably, shadows cast by these clouds onto a lower haze approximately 50 kilometers below are also visible, illustrating the complex atmospheric dynamics of Neptune. Despite Voyager 2's exploration of all 4 outer gas planets, it wasn't until its arrival at Neptune that cloud shadows were observed for the first time, as shown in a grainy image. These high-altitude clouds are known for their transient and ever-changing nature. Recent observations from telescopes like the Hubble Space Telescope have further demonstrated that these clouds can form and dissipate rapidly, highlighting Neptune's dynamic atmosphere. Zooming out from these observations reveals thick white clouds scattered across the planet, swiftly rotating as they drift. Beneath these clouds, dark bands reminiscent of Jupiter's atmosphere can be discerned, although they are less distinct and seem to blend into Neptune's blue haze. During Voyager 2's encounter, powerful winds were recorded whipping around the ice giant at speeds of up to 2,100 kilometers per hour, 3 times faster than Jupiter's winds and nearly 9 times faster than Earth's. Voyager 2's observations revealed Neptune to host some of the solar system's most extreme weather phenomena. One such phenomenon is the Great Dark Spot, captured in the closest image ever taken of this once potent storm. Resembling Jupiter's Great Red Spot, the Great Dark Spot is an oval-shaped anticyclone approximately the size of Earth. In contrast to its surroundings, the interior of the storm appears relatively cloud-free, resembling a vast, dark vortex churning through Neptune's atmosphere. The exact reason for the storm's darkness remains unclear, though it is believed to involve certain particles darkening within Neptune's lower atmospheric layers, posing a mystery yet to be fully understood. Winds encircling the Great Dark Spot were among the fastest recorded in the solar system, reaching speeds up to 2,400 kilometers per hour. These high-speed winds contributed to the storm's turbulent and dynamic nature, as evidenced in remarkable footage showing large white cirrus clouds high above, partially veiling the storm's shifting dark and light regions. In contrast to Jupiter's enduring Great Red Spot, which has persisted for centuries, Neptune's Great Dark Spot was observed only for a few years. By the time the Hubble Space Telescope captured images of Neptune in 1994, the spot appeared to have vanished, suggesting it was a temporary atmospheric phenomenon. However, Voyager 2's exploration revealed more than just the Great Dark Spot. To the south, another significant feature known as the Small Dark Spot is visible. Upon closer inspection, rotating clouds within this feature resemble a giant eye peering out into space. The formation of these colossal vortex storms remains largely mysterious, though it is believed to involve internal heating from Neptune's enigmatic core. During its flyby, Voyager 2 also captured striking images of Neptune's south pole. Due to the planet's axial tilt during the approach, these images primarily depict bright clouds at high altitudes. Yet, upon careful examination, a peculiar feature becomes apparent. By combining 5 distinct photographs of this region into a polar projection and enhancing contrast, a strange hexagonal storm emerges, a phenomenon reminiscent of Saturn's hexagonal polar storm, so vast that nearly 4 Earths could fit within its boundaries. 35 years ago, a spacecraft equipped with 1970s technology achieved one of humanity's greatest feats, visiting all 4 outer planets and revealing their magnificent splendor. While these images hold enduring historic and scientific significance, advancements in modern camera technology offer the potential for even greater views of Neptune, akin to those we enjoy of Jupiter, for instance. Perhaps it is time for a new mission to encounter Neptune, but the question remains, will we return? Unfortunately, as of 2024, there are no approved future missions to Neptune or Uranus, the 2 most unexplored planets in our solar system. The primary challenge lies in their immense distance. Such missions necessitate precise timing, utilizing Jupiter's gravitational assistance to propel spacecraft towards these distant targets, an approach successfully employed during the Voyager Grand Tour mission decades ago. This alignment with Jupiter occurs approximately every 12 to 13 years, with the next opportunity anticipated in the early 2030s. Thus, we face a considerable wait if we hope to capture new close-up images of these mysterious ice giants. For now, we must rely on the spectacular photos captured by the Voyager 2 spacecraft. Personally, I find myself continuously captivated by these images, pondering the secrets hidden within Neptune's majestic blue clouds. And that's it. I hope you found this video enjoyable. If so, please remember to like and subscribe. For those eager to delve deeper into the universe, consider clicking on this video. Thank you for watching, and I look forward to seeing you next time.